am Teacher Alin and I welcome you all to another fun-filled discussion. Before anything else, I invite you all to subscribe to Math Nation's channel and hit the notification bell so you'll be notified every time we have new uploads. This week we will talk about illustrating angle of depression and angle of elevation. Let us define angle of elevation. An angle of elevation is the angle formed by horizontal line and a line of sight to a point above the line. Let's take a look at this example. AB is what we call the horizontal line of sight, or simply the horizontal line. AC is what we call the line of sight. It is the line formed from the observer in point A to the object in point C. And the space between the two lines are called the angle of elevation. Now let's define angle of depression. An angle of depression is the angle formed by a horizontal line and the line of sight to a point below the line. Let's look at this example. PQ is our horizontal line, and the observer in point P is looking at the cat in point R, so it's downwards. PR here is our line of sight, and the space between the two lines is called angle of depression since the observer is looking downward the object. Take a look at the examples of angle of elevation and angle of depression from your modules. What can you say about the two? Can you differentiate the two? Very good! The angle of elevation denotes the angle from the horizontal line upward the object, while the angle of elevation denotes the angle from the horizontal line below the object. Let's have some more examples on how to differentiate the two angles. So in here, we will identify whether the picture shows angle of depression or angle of elevation. So you will be given 5 seconds to answer. Let's start. Okay, time's up. The answer is angle of elevation. Very good, because you can see there the horizontal line of sight and the line of sight, and the angle is here. The girl is looking upwards, so it's angle of elevation. Let's have the next one. Okay, time's up. The answer is still angle of elevation, because you can see here the angle 65 degrees and it's upward. So this is an angle of elevation. Okay, time's up. The answer is angle of depression. Why? Because as you can see, here is the horizontal line of sight, meaning to say the observer is above the tower and he or she is looking downwards the plane. That will be your line of sight, and 19 degrees here is your angle of depression. So this picture shows an angle of depression. Okay, time's up. This is an angle of depression, because as you can see, the boy is looking downwards the ball. And this is the horizontal line of sight. This is the line of sight. And the angle there is what you call the angle of depression. At this point, let's solve some problems involving angle of elevation and angle of depression. The angle of elevation of the top of an electric post at a point 3 meters away from its base is 65 degrees. Now, the problem is how high is the electric post? To determine the height of the electric post, we first draw the figure to visualize the problem. So it is shown in your module. An electric post is drawn. From the base of the electric post to a certain point measures 3 meters. And when we connect the tip of the electric post and the point, an angle of elevation of 65 degrees is drawn. Now let's write the given figures. We have the angle, which is 65 degrees, and an adjacent side. Let's recall the meaning of adjacent. It is a non-hypotenuse side that is next to the given reference angle. And in this problem, it measures 3 meters. Now, given the angle, what side is unknown? Very good. The unknown is the opposite side. Now, what trigonometric ratio will we use? If we are given the adjacent side and we are looking for the opposite side. Excellent. We're gonna use tangent. And what is the formula in getting tangent? Very good. We'll have the opposite over adjacent. Now let's substitute the values. Tangent 65 degrees, that's given, is equal to opposite, which is h, over the adjacent, which is 3 meters. We will multiply both sides by 3 so that we'll get the value of h, which is the height. H now is equal to 3 multiplied by tangent 65 degrees. And if we encode tangent 65 degrees in our calculator, we'll have 2.1445. So 3 times 2.1445, H now is equal to 6.4335 or 6.43 meters. Therefore, the post is approximately 6.43 meters tall. Let's have an example for angle of depression. From the top of a 120 feet tower, an air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. Now the problem is, how far from the base of the tower is the airplane? Let D be the distance from the base of the tower to the airplane. Now, applying the theorem, alternate interior angles formed by parallel lines cut by a transversal are congruent. We have this illustration. We are given the angle, which is 19 degrees, and the opposite side, which is 120 feet. Now, what is asked or what is unknown? Very good. The adjacent side is unknown. And what trigonometric ratio will we use? Excellent. We'll also use tangent since an opposite is given and the adjacent is unknown. To determine the distance, we proceed as follows. Turn your modules to page 15. Tangent theta, what is the formula? Excellent. Opposite over adjacent. Now we have tangent 19 degrees is equal to what is the measure of our opposite side? Very good. It is 120 over our adjacent side, which is unknown. The distance now is equal to 120 over tangent 19 degrees. So if we put that in our calculator, the distance is 348.51 feet. Therefore, the distance from the airplane to the post is approximately 348.51 feet. For today's task, please answer the activities provided by your teacher. If you have questions or clarifications, you may reach your teachers in your group chats. And that ends our lesson for today. Again, this is your teacher Alin, and don't forget that math is fun. Let's do it.